Myself, Karanam AJITH, Assistant Professor, Vijayanagara College, Hosapete. Now in today's session, we shall understand what are the factors affecting the velocity of sound in air. The factors affecting the velocity of sound in air are pressure, temperature, density, humidity, and wind. Now let us understand what is the effect of pressure. For a given temperature, the velocity of sound in air is given by V is equal to square root of gamma P by rho. According to the equation of the state, PV is equal to RT. If M is the molecular weight of the gas and rho is the density, then the volume is equal to mass by density. Mass is equal to volume into density, or volume is equal to mass by density. Therefore, PV is equal to RT becomes P into volume is given by M by rho, that is equal to RT. Or if I take P by rho is equal to this value of M is being transferred here, it becomes RT by M. Therefore, P by rho is equal to RT by M. That is, at constant temperature, if P changes, rho also changes in such a way that the ratio P by rho remains constant. Therefore, at constant temperature, the velocity of sound in air is independent of pressure. Now, what is the effect of temperature? The velocity of sound in air is given by V is equal to square root of gamma P by rho. Now we know that PV is equal to RT, or P is equal to RT by V. In place of P, we substitute this as RT by V. Then the velocity V is equal to square root of gamma by rho into P. In place of P, we take this as RT by V, or V is directly proportional to square root of T. Therefore, velocity of sound in air is directly proportional to square root of absolute temperature. That is, at 0 degrees Celsius, velocity of sound in air is V0 and is given by V0 is directly proportional to square root of 273. At T degrees Celsius, the velocity of sound in air is Vt and is given by Vt is proportional to square root of T plus 273. Now taking the ratio Vt by V0 is equal to square root of T plus 273 by square root of 273. On simplification, Vt is equal to V0 into square root of 1 plus T by 273. Now, if you transfer this, it can be written as V0 into 1 plus T by 273 to the power of half. Now, this which can be expanded by binomial expansion and ignoring the higher order terms, then we get this as V0 into 1 plus, this half is taken inside, that is equal to half of T by 273. That is equal to V0 into 1 plus T by 546. 2 into 273 is 546. Therefore, Vt is equal to V0 plus V0 by 546 into T. This is a very important expression. Now it is observed that the velocity of sound in air at 0 degrees Celsius is 330 meter per second. V0 is equal to 330 meter per second. At T degrees Celsius, velocity of sound is given by Vt is equal to 330 plus 330 by 546 into T. In place of V0, we take this as 330 by 546 into T. That is equal to 330 plus, when we divide this component, we get this as 0.61 into T. This 0.61 indicates the fact that the velocity of sound in air increases at the rate of 0.61 meter per second for every 1 degree rise in temperature. That is the importance of the effect of temperature on velocity of sound. Now, what is humidity? The presence of water vapor in the atmosphere is the measure of humidity. Greater the humidity, lesser the density. The density of water vapor is less than that of dry air. Therefore, V is equal to, V is directly proportional to 1 by square root of rho, or lesser the density, greater the velocity. Thus, the velocity of sound is more in humid air than in dry air. Now, what is the effect of wind? When the wind blows, the velocity of sound changes. If V is the velocity of sound and W is the velocity of wind, then when the wind blows in the direction of sound, then the resultant velocity of sound is V plus W, and it increases by a factor equal to V plus W. That means if V is the velocity of the wind or velocity of sound and W is the velocity of wind, when they both are traveling in the same direction, the velocity of sound increases. It increases by a factor equal to V plus W. When the wind blows in a direction opposite to that of sound, then the resultant velocity of sound is V minus W, and it decreases by a factor V minus W. That means if V is the velocity of sound, W is the velocity of wind, when they are moving in a direction opposite to each other, the velocity of sound decreases. It decreases by a factor V minus W. In other words, when the wind blows along the direction of the sound, the velocity of sound increases. When the wind blows in a direction opposite to that of velocity of sound, it decreases by a factor V minus W. Hence the effect of wind on velocity of sound. Thank you.